Okay, 2.0 prerequisite skills for probability. So we're going to first focus on fractions, decimals, and percents. So we're going to just embed examples. So example 1, we are going to express each fraction. Okay, we have 3 fractions here. We're going to express it as a decimal just using your calculator. And we're going to round the answers to 4 decimal places. Okay, so taking a look at 27 over 40. This line right here means division, as a reminder. So in our calculators, you should be able to do 27, press the division symbol, divided by 40, and then press the equal symbol. And I get 0.675. Okay, so now I'm going to do 63 divided by 80. So again, this is division. So we're going to go 63, hit the division sign on your calculator, 80, then hit the equal sign. Okay, and you're going to get 0.7875. Okay, and 45 divided by 75, you're going to get 0.6, and that's going to stop there. Okay, example 2, express each fraction in lowest terms. So when we talk about lowest terms, what we're going to do is we are going to find a number that both the numerator and the denominator divide by. Okay, so when looking at 65 and 80, 65 ends in a 5, 80 ends in a 0. We're thinking, what number can we divide 65 by and then divide 80 by that same number? Well, it's going to be 5. And just to let you know, if you don't choose the most optimal number, that's okay. And then maybe in the next step, you're going to have to divide again. But that's okay. Just take like those baby steps and it's fine. Okay, so 65 divided by 5, we get 13. And 80 divided by 5, we get 16. Now we have 13 divided by 52. What number can we divide 13 by? And then the same number, what number can we divide 52 by? So this one's a little bit trickier, but it is actually 13. If you think about the number 13, 13 is a prime number. The only factors of 13 are 1 times 13. That's it. Okay, so 13 divided by 13 is 1. 52 divided by 13 is 4. So we get 1/4. Okay, and don't forget what the purpose of this was. We found an equivalent fraction. So 65/80ths is the exact same thing as saying 13/16ths. And 13/52 is the exact same as saying 1/4. All right, example 3. Express each decimal as a fraction in lowest terms. So what we're going to do is we're going to take a look at how many decimals our number has. So in this case, we have 2 decimals. What we want to do is we want to come over here to this place value chart and we want to locate the decimal. So then we're talking about not tenths, but hundredths. So because there are 2 decimals, we can actually convert this to 46 over 100. Because it's just like saying 46 hundredths. So then we're going to put the hundredths on the bottom. Okay, and from here, all we want to do is we want to find the lowest terms. So just like we did in example 2, what number can 46 and what number can 100 divide by? And it's got to be the same number. So looking at this, I kind of have no idea, but I know they're both even numbers. So let's start by dividing by 2. Let's see where we get to. So 46 divided by 2 is 23. 100 divided by 2 is 50. And we're actually done. Okay, 23 is a prime number. So the only numbers that multiply to 23 are 1 and 23. Okay, which 50 is not divisible by, so that's it. All right, for B, we have 0.75. So again, this is 2 decimals, so we are going to divide by 100. In other words, like 2 zeros. So we're going to write the number after the decimal and divide by 100 because it's 75 hundredths. So in this, what number can we divide both 75 and 100 by? So if you can think of the highest number, it's fine. But looking at 75 and 100, you might only be able to think about 5. Okay, so in other words, you're like, okay, well, what's 75 divided by 5? Well, you would get 15. And what's 100 divided by 5? You'd get 20. So if you divided by any number here, and you're looking at 15 over 20, you have to still assess, did I divide it by the biggest number that I could have? Or can I keep going? Okay, and in this case, we can actually keep going. What number can both 15 and 20 divide by? Well, 5 again. 15 divided by 5 is 3. 20 divided by 5 is 4. Okay, I'm just going to point this out though. See how we divided by 5 and then 5 again? Well, 5 times 5 is 25. 25 would have been the biggest or the largest common factor. So if you saw 25 right off the bat, perfect, just divide by 25. If not, just know that you're safe if you just continuously divide by different factors or the same factor, 5 and 5. All right, example 4. Express each percent as a fraction in lowest terms. So this symbol right here actually means 1 times 1 over 100. Okay, it's percent or per 100. And the prefix per is division. Okay, so if we have 20%, we're going to rewrite 20, and then the percentage symbol, we're going to write it as times 1 over 100. In other words, we get 20 divided by 100. So we want this fraction in lowest terms. So what can we divide both 20 and 100 by? Well, we can actually divide it by 20. So 20 divided by 20 is 1. 100 divided by 20 is 5. We get 1/5. So 20% is equivalent to 1 over 5, 1/5. Okay, now B, 65%. So we're going to rewrite 65 as it is. And this percent symbol, we're going to multiply by 1 over 100. So to rewrite this, we're simply doing 65 over 100. So 65 divided by 5, and 100 can divide by 5 as well. So we get 13 over 20. And again, 13 is a prime number. So the only numbers that multiply to 13 are 1 times 13, and 20 cannot divide by 13, so we're done. Oh, now we're going to talk about interpreting data with probability. So example 5, what type of graph is this? Okay, so this is a bar graph, and we can tell because there are spaces between the bars. Okay, if there were no spaces, it would be a histogram, but this is a bar graph. Okay, the other thing is we can tell here because these, Rihanna, Madonna, Mariah Carey, Michael Jackson, and the Beatles, this is not numerical. Okay, this is categorical. So it's like these are categories. Okay, so how many #1 hits did these 5 artists collectively have? Well, let's take a look at like what we're actually talking about. So these are top 5 artists with most Billboard #1s. Okay, so there's 5 artists here. And going up the side, this is numerical. These are the number of Billboard #1s. Okay, numerical. And then these are the artists. So how many #1 hits did these 5 artists collectively have? Collectively means all together. Okay, so let's actually count. And what I do is I usually count and put the number on the top here. So Rihanna has 11, because that's 10 and 12, right? Madonna has 12, making Mariah Carey 12, right? Those are the same height bar. Okay, this is going to be 18, 14, 16, 18. And the Beatles are going to have 20. So altogether, we would do 11 plus 12 plus 12 plus 18 plus 20. Right? Altogether just means add them all up. So we get altogether 73, I believe. 2, 3, 4, 5, 6, 73. Yep. And now let's compare. Who had the most #1 hits? Okay. And then the least. So the most is going to be the highest bar. So visually, we can see that. That's the point of a bar graph for the visual. Okay, the Beatles have the most #1 hits. And visually, the least #1 hits is Rihanna. Okay, what fraction of #1 hits did the Beatles have? Okay, so when we're thinking of a fraction, what we're thinking of Beatles #1 hits divided by total hits. Total #1 hits. Okay, so the Beatles have 20, but the total, which we already found out in B, is 73. So the fraction of total hits that the Beatles had was 20 out of a total of 73 for these 5 artists. Okay, and what percent of #1 hits did Madonna have? Okay, this time we're finding the percentage. So I'm going to start this as a fraction. Madonna had 12 out of 73. But what we want to do is we want to put that into our calculator and we just want to divide it, just like we did in example 1. And we get 0.16. So she has 16%. That's how you read that. Okay, example 6. A company sampled the heights of black cherry trees. So before even going on, we have a graph over here. It's called the heights of black cherry trees. And we have the height in feet along the bottom axis. And if you notice, we have like 60 to 65. So what this is called an interval. And that means that we don't actually know if, for example, from frequency up the vertical axis, we don't know if these 3 black cherry trees were all 60 feet in height, or all 65 or 61, 62, 64, whatever it is. We don't know. We're just saying 3 of these trees are within 60 to 65 feet tall. Okay, and then 65 to 70, we have another interval. And then 70 to 75, we have another interval. Okay, so intervals group a bunch of numbers. So, A, how many black cherry trees did the company sample altogether? Okay, by the way, I want to point out, and please make a note, this is not a bar graph. This is a histogram. As you can see, the bars touch. Okay, that's how we can tell it apart. And then also, so the bars touch, and it's an interval and numerical. Okay, so A, how many black cherry trees did the company sample altogether? So what I'm going to do is I'm going to do just like I did with bar graphs. I'm going to put the number for that interval over the bar. So 3 for 60 to 65, 3 for 65 to 70, that will be 8, that will be 10, this will be, well, obviously between 4 and 6 is 5, and then, yeah, this is 2. Sorry, I drew it up a little bit. Okay, so all together means total. So we're going to add 3, 3, 8, 10, 5, 2. Okay, so 3 plus 3 plus 8 plus 10 plus 5 plus 2. Okay, and when we add all these together, we get 31. Okay. What was the most popular height of black cherry trees and the least popular? Okay, so I'm going to say most popular and then least popular. And then what I'm going to do is I'm going to look at the bars. Well, the tallest bar is going to be the most popular with the frequency of 10, and that is going to be 70 to 80. Sorry, 75 to 80 feet. Now, the least popular is going to be the shortest, or the least frequency, which is going to be this one here, 85 to 90 feet. Okay. C, how many black cherry trees were between the heights of 70 to 75 feet? How many? So how many would be here, 70 to 75. So it'd be this bar here, it'd be 8. And then what fraction? So when we talk about what fraction, we're thinking what fraction of the total. So in other words, it's 8 out of the total of 31. Okay, and D, how many black cherry trees were shorter than 50 feet? And then also what fraction? Or sorry, 80 feet. So I'm locating 80 feet. So what we have to do is we have to do anything less than 80 feet. So we have to consider all of these black cherry trees. So we have to consider 3 plus 3 plus 8 plus 10. All of these black cherry trees are going to be less than 80 feet. So 3 plus 3 plus 8 plus 10. I get 24, which gives us the fraction 24 out of a total of 31. Okay, so 24 out of 31 black cherry trees are shorter than 80 feet.